Okay. So hi guys, thank you for coming. My name is Mario Fusco. I work for Red Hat and I'm the project lead of Drools. By the way, as Federico anticipated during the keynote, I'm also among the organizer of Voxed Days Milano. So probably the date will be the 16th on May. And I guess we will open the call for paper in like 1 month. So please stay tuned and then join us in Milano if you want. Okay, that's about me.
Yeah, my name is Maciej Swiderski. I work also at Red Hat and I'm JBPM project lead. Yep.
Yeah, and what is talk about? It's about basically 3 things. Okay, yeah, of course it's about our 2 projects, Drools and JBPM, that actually are engineering to work together. And we want to quickly demonstrate and introduce what they are, how they work. But you should consider, about this talk, you should consider them just our playground, okay? The context when we applied the re-engineering that we would like to discuss today. So we will mainly speak about GraalVM, which is this new virtual machine by Oracle, and Quercus, which is this new framework, a lightweight framework developed by Red Hat, and that is optionally based on GraalVM. Okay, so yeah. About Drools, Drools again is the rule engine of Red Hat. I don't know how many of you are familiar with a rule engine, but basically a rule engine is based on rule, which is a different way of programming. It's more a declarative way. If you think about it, it's closer to the business domain because the business always reason in rules. If something happens, then do something else. So it is closer to the business, and it allows the business to reason easily on the domain, better modularity of your business. And also, it allows a clear separation between the infrastructural code and the business domain code. And probably you may want to do this also because they have 2 very different life cycles, meaning that your business domain code can potentially change every day. Let's think to a marketing application for an online travel agency. They change their mind every day, basically, or every minute. So probably you want to change the stuff very quickly. Why the infrastructural code is there, and it will be basically unchanged for years. So this is how our rule is made. So our rule is composed by mainly 2 parts. The first one is what is called the left-hand side part, is the pattern matching part where we matching the object on which the rule is reasoning against a certain constraint. And then the right-hand side part, the consequences of the rule, is what happens when the rule when the rule engine finds a match for those constraints, and then the rule can be executed. Okay, I will return on the syntax of the DRL, but in the context of the changes and optimization that we had to do to make it work with Graal.
Right, and moving to the next project, JBPM, and that is a toolkit for building business applications that help to automate your business application to achieve a certain goals. And it takes advantage of the rule engine, process engine, and to some extent the optimization as well. So you can take a look at the BPM or process management in general as a flow chart, although they might be structured and might be unstructured, so it might be completely interconnected nodes or might be loosely coupled. So it's really up to your business goal how you define them, and we support the multiple formats of defining your business processes like BPMN2, which is the main one. but as well we can use the case management or the decision management and the business rules as well. So as I said, the business process is pretty much defining what needs to be done to achieve a certain goal, and usually it is a flowchart, but it doesn't have to be. As I said, it might be an unstructured process, so you can have a process fragments that define different ways of achieving a business goal. So looking at the content or the title of the presentation, we wanted to sort of look at the projects that we've been working for a couple of years, and maybe not to call them old, but we usually try to call them mature, to make sure that we can actually start moving them into more cloud native or modern way of developing software these days, but still take advantage of the years we spent on building the experience and sort of battle-tested features that we have there. It's been used in various industries in quite successful way. So we don't want to throw it away and start from scratch, but take the good parts of it and have the opportunity to as well drop things that might not fit into the new world anymore. So that led us to introducing a CodeIto project. And I usually, when introducing CodeIto, I talk about how you should spell CodeIto, but I think we are in the location that we don't have to do that. But what CodeIto comes from is actually from the quite famous Latin quote, "Cogito ergo sum," and then I think therefore I am. So we just tried to put that into context of business automation, and we came up with the name Cogito ergo automate. So it means that I think therefore I automate. And that brings us to taking advantage of both rules, decisions, and processes and cases to actually start building your software instead of trying to hand code everything. So CodeIto is built up of the Drools, JVPM, and upcoming Optaplaner project as well to bring this automation into the new world. But at the same time, it is quite significantly changed. So it reuses the core components, the engines themselves, but puts this in a completely different context. So the CodeIto itself has like three main themes. One is to be the ergo cloud. So you think about cloud because this is pretty much where your business will run anyway. So it needs to be designed from ground up to run at scale, to be able to dynamically scale up and down. Take advantage of the cloud provider solutions like Kubernetes, so it plays well there. So it's not just designed outside and all of a sudden let's put it in the container, put it into a container orchestration platform. It takes advantage of the business assets, how you design them. So it's processes, rules, decisions, and transforms them into running services. So you don't have to spend much time on understanding, okay, how do I transform this business process or these business rules into running service? So my clients can simply consume those. So this is what happens behind the scenes with the code generation. We're trying to be, as the next main theme is to be sort of ergo domain. So we don't want to put you in a position that all of a sudden you need to take advantage of the technology itself, but you put the domain data in front of it. So instead of looking at the technology underneath, you look at the domain and what the domain is built up. So that means that we can actually take advantage of the type-safe APIs, like the REST API, so it brings in your data in front. If you interact with CodeIto services, you don't even see that there is a process or rule behind it. You simply will interact with your domain models. So again, all the goals that we have here is to be able to run at scale in the multiple environments. Even though we target the cloud-native environments at first, it doesn't mean that you cannot run it on-premise. It's exactly the same, so you can still take advantage of the code generation, the years of experience for the battle-tested features we have. And again, it's not just Drools and JVPM. It's everything that we can actually consume from the ecosystem, like Quercus or different native image compilation and so forth that we're going to talk today about. And again, we wanted to bring back the control to developers. So it's not that it's just the business users behind it. You, as a developer, control what are the rules, how they are written, how the decisions are written, how business processes are designed, and so on and so forth. But at the same time, you take advantage of those business assets as a way of communicating with your business audience as well. And as mentioned, we take the advantage of the knowledge that you gather within your organization and build up your business processes or decisions and so on and so forth. And we simply transform that from the models into running service. The running service could be pretty much anywhere. It might be directly deployed into a cloud. It might run on your IoT device and so on and so forth. So it brings all the knowledge that you have into running service. And we want to start first, not just talk about this, with a short demo on an onboarding service. So this is an application, sort of an application that shows the different aspects of CodeIto, bringing in the onboarding, which is the process, the payroll, that is a decision, and then the HR is a set of business rules. Those are individual services composed out of the business assets and then bound together through the onboarding, which is kind of a service orchestrator described as a business process. So this is the main process, still rather simple, but at the same point shows that different aspects, how it actually interacts with the different services. So the validation of the employee is calling a service, the HR service, that is responsible for verifying if a particular employee needs to be onboarded or not. And depending on the decisions, we either finish the process with an error, because it's already done, so it doesn't make sense to continue with that, or we run then a bunch of additional steps. So assigning ID and email. Based on that information, we can move on and then spin off with so-called a process composition. So we call a different set of processes that are responsible for setting up the payroll and setting up the HR information, finishing up with the manager confirmation. So let's get it up and running. So while Mario is starting this up, this all runs right now as a Quercus application compiled to a native image. So as you can see, we take advantage of pretty much everything that the Quercus and native image gives us. So we have the startup time of the services of 7 milliseconds. And again, this is a 10 years project of the core engines running right now in a completely new environment, taking advantage of all the new things, while the same, and for those that actually use that, you will still feel familiar with the content, how you design your processes, how you design your rules. And then you can actually move it like years ahead with all that stuff that we can take.
Just to be clear, I created a native image of my project that is based on Drools in this case. And I'm just starting that native image. And as you can see, it takes just 7 milliseconds to start. So
yeah, we can start to other services. So the other one
we can also probably give a look at the memory footprint of this thing. As you can see, it is taking like 22 megs. So it's super fast and very small, considering the amount of technologies we are using in it is very small. As memory occupation, okay? So I started, as Maciej said, this example is made of 3 different independent web services. So I started the first. I will start the second here, which is the one for the payroll, and this is the JBPM-based one, which coordinates the 3 things, okay?
Yeah, so all of them are actually now up and running, so we can start interacting with them. And here, before we actually send the request, we can show that this is, again, you don't see anything from an underlying technology. So you're not sending requests to like a startup process, or call a decision, or evaluate decision, or evaluate rules. You simply put the domain data into the service, and you want to get it back. Again, you don't see any interaction with processes, rules whatsoever. That gives you the opportunity to actually, if you find the need, you can swap the actual technology underneath with still keeping the same API. So you won't affect the clients changing it. For instance, when we build this demo, at first, all the 3 services were built with processes. And just before one of the presentations we gave with that, we swap the implementation for the HR to use the Drools and DRLs, and the payroll we change with decision tables and DMN, without affecting the main orchestrator process, because they simply take advantage of what is the API contract, and we don't care if it's process, decision, or rule. You simply can just interact with that, sending the data that you wanted to evaluate. And in this case, we wanted to send Mr. Mark Test to be onboarded as an employee, so we simply send it over. And based on that information, we get the information, all things that happen. So we assign the user ID, we assign the email, we assign the manager, we assign department. Based on that all information, we completely onboarded a particular employee. But again, if we look at the process itself, that validates the employee first. So if we send the request again, the first evaluation of the rule says, okay, the guy has already been onboarded, so it doesn't make sense to continue. So this is already existing employee, and the process finishes. Again, you don't see that this is a process or not. You simply get the information about a particular execution in the context of your domain. The only thing that is actually added on top of this domain information is the ID. But at the same time, you pretty much identify anything that you exchange as part of the ID system. So anyway.
Yeah, so I can probably change the ID, I don't know how. Okay. Anyway.
That's the response. So you should scroll up.
Scroll up, yes. Where is that?
That's the bar.
Okay.
It's too advanced technology for me.
Yeah.
Usually,
I don't
terminal, not.
I just use the C URL. I don't like this fancy thing, but you can see. Sorry, you can see that now I'm requesting the onboarding for a different user, meaning that I change it the personal ID, and then it is running the onboarding process again. Okay. So this is all nice. We have this super fast and with very low memory footprint servers. But how did we get there? Which is the most important part of this talk. We get there through two technologies. First of all, we wanted to take advantage of GraalVM. GraalVM is this new virtual machine. It's a polyglot virtual machine, meaning that doesn't only support the languages that you are used to use on the JVM, but you can use also, for instance, dynamic languages like Ruby and other stuff that are not languages like JavaScript. And you can have them all compiled together, and the good part is that it can do cross languages optimization. So if you, I don't know, you are used to have inlining of one method into another if the method is small enough and is called frequently enough. The hotspot, the just-in-time compiler, does this for you. GraalVM does exactly the same thing, but it's able to do the same thing cross-language. So if the called method is developed in a different language or in JavaScript, it can be inlined as well. Okay. So this is one very fancy and nice thing. The thing that mostly interested us is the possibility, as I anticipated, to create a native binary image of your project. Okay. But in order to get there, you should comply to some, let's say, limitation for now. The main assumption that GraalVM does is what is called the closed world assumption. Okay, so what GraalVM does is that it doesn't do a just-in-time compilation like Hotspot does, meaning that while your Java programming is running, Hotspot is doing those inlining, branch prediction, and other optimization like this. GraalVM does this ahead of time. So not while your program is running, but while you are compiling it. Okay? And in order to do this, it has to rely on this closed world assumption. What does it mean? It does mean that it has to know upfront what's going on in your program. Okay? So of course, it means that you cannot do dynamic class loading. And you cannot do reflection, or there is a limited support for reflection. In this way, you can have this super fast process with a very fast startup and with a lower memory footprint. So, yeah, the main two things that was a problem for us, again, was the dynamic class loading and the fact that you should really avoid the reflection, Okay, and why this is a problem for us? Because let's give a 1 second look to a typical rule. The rule is made of two parts. The left part is the one evaluating the constraint, and what we typically do there is using reflection. Okay, I have this sprinkler object with property, Boolean properties. In this case, I access it via reflection, I evaluate it, and I know if the sprinkler is on or off. Okay, and so this is the first part. The second part is probably even harder and worse for Graal, because the right part of the rule, which is the code that has to be executed when all the objects are matched. We take it, we translate into Java code, we put it into a static method, into a class, and we compile the class on the fly, and we do the dynamic bytecode loading of that stuff, which is totally incompatible with Graal. Okay, so we had to overcome this limitation, and in reality, yes, it's true, these are limitations. So this stuff, for instance, doesn't work. I cannot do a dynamic loading of a class. But viewing on it at the end of this rewriting process of our project, I can say that, yes, it is true that they are limitations, but I believe that they also give us a chance to review our code for better. I mean, we were abusing of this thing. We were abusing, well, the dynamic class loading was a need. We were abusing of reflection, for instance, which also slowed down your application, even in a plain Java virtual machine based execution. Okay, and then you don't have other stuff, like you cannot use Java agent. So you, for instance, stuff like Jarable or Byteman doesn't work. You cannot do auto reload of your code, and you cannot use JMX, but you can do monitoring with other technologies like what's the name, Prometheus. And well, you have some other limitation, like you don't have a proper security manager. Okay, I'm hoping that you are not using the finalize anyway. They were not so important for us. The other thing really important, as I said, is reflection. Okay, so you had to comply with this closed word assumption thing, meaning that Graal at compile time needs to know what is going on in your code. So if you really need reflection on a specific object, you can put a list of the class on which you need reflection in a JSON file. Then you pass the path to the JSON file to the command line when you do the native compilation, and Graal sort of work with this. But I used a lot this thing in the early stages of this migration of Drools toward the Graal, full Graal compatibility, because it was a shortcut for me. But nowadays, we are not using reflection anymore. Okay? So what we did, we resolved our problem with code generation, basically. Okay? So what we did is that we have that rule there, which has the constraint, which has the consequence. And what we did is that we have another stage before the compile time, which is the code generation phase, where we translate the rule into pure Java code. Okay, so all the constraints are translated into predicate, and the consequence is a lambda itself. Okay, so everything becomes a pure Java code through code generation. Of course, you don't have to write this stuff on your own because it's very verbose, but it's automatically generated for you. And the other thing that I want to make you notice is that in this stuff there is much more than in the Drools language representation. Why? Because from the Drools language we can infer stuff like the indexing of the different constraints. But and we use lots of reflection also there, and we don't want to. So in this thing, in this Java representation, which we call the executable model of the rule, we also have to explicitly say on which how you are, for instance, indexing a specific constraint, okay, which is not implicit anymore for the Java representation. We want it to totally explicit, otherwise we couldn't get rid completely of reflection. And of course, yeah,
and similar, we have the executable model for processes. So it's again not only the expression in allowing us to get rid of anything that requires a parsing XML files, reading data structure, building up the, as Mario mentioned, the references to reflection and so on. But at the same time, it opens the door for having different formats. So our default one is BPMN2, but at the same time, we're now looking into serverless workflow specification to have a JSON representation for the workflow. So it pretty much gives you the opportunity to even write your own parser that just simply goes into that and have the all the capabilities of the engine exposed to you.
Okay, so with these changes in place, we didn't need to use dynamic class loading anymore. So we have a different version of our of the Drools class loader that is not doing any dynamic class loading anymore. And yeah, you will find that you have similar problems in other parts of your code. For instance, we are used to have this XML descriptor that on which you can set some properties and option of your the Drools session that you want to use, and we used to have this in XML. But when you try to parse the XML, guess what? You are using tons of reflection, so same problem. So we solved the problem exactly in the same way. We read that XML at code generation time, and we translate it into a Java class representing exactly the same thing, okay? And the last thing that I had to do is that we also have a few, well, the Drools is a modular rule engine, and each module has a configuration file. So when a module is present, it's providing a given service to the engine, and that service is implemented with a class which is in this configuration file. Guess what? This doesn't work as well. So what we have to do is that we translated this into that. And the trick is that if you do class for name with a variable, Graal doesn't know what it is because it doesn't know what the variable is. But if you do class for name with a constant, then Graal at compile time knows what class is that. So you are not violating anymore the closed word assumption. Okay, so with all these changes in place, yeah, I played with this stuff during my last Christmas vacation, actually, and the Christmas evening, I had the very first version of this working on Drools, and I was really excited. I sent an email to my colleagues, and this was really the result, and it was very encouraging because if you launch exactly the same thing by using the Java virtual machine. So I have this very simple service that through which you throw some object, it evaluates a few rules against that object and then shut down. Okay, and then if you do this in the Java virtual machine traditional way, you can see it took like 730 milliseconds, and it took 103 megs of memory, okay? And finally I was able to natively compile with Graal, and at that point you see that the execution time is sub-millisecond, and the memory occupation is just 16 megs. So huge win, okay? I don't know if I can say quite a big effort, but we did some work on it to make it work, but it worth the effort, okay? And then we have been lucky because in the same period, Red Hat was starting creating and working on this new framework, which is called Quercus. Quarkus is a lightweight Java framework which is optionally based on GraalVM. What does it mean is that you can use it as a traditional Java framework with lots of integration with the technologies that you are used to use, like, I don't know, Drools, JBPM, of course, but also Camel, Prometheus for monitoring, and Hibernate and Vertex and stuff like this. And that's all nice, but what is even nicer is that Quarkus gives you a chance to have a native image based on Graal of your code. Okay, so you do this traditional Java application with this component that now are all compatible with this programming model. And then at this point, you are able to create your own native executable through Quarkus, which is based on GraalVM. Okay? So the reason why you may want to use this stuff now should be clear. This is optimized for short-living processes, so it's mainly for, one of the goals initially was to have Drools to be decision as a service service. Okay, so you can think about it like a function call, where the function is implemented with rules, with business rules in my case. Okay, so I want to have something super fast that you can call, and when you call it, it creates this native image, execute your rules, and shut down, which is the function as a service paradigm. But if you try to implement it with the Java virtual machine, you will see that it's not possible because of the long Java virtual machine startup time. And Quarkus and Graal solved this problem. So you have a process that is as a low memory footprint, a super fast startup time, and it's cloud native. And as we demonstrated, it's a perfect fit for microservice. And you can also have live reload, as we show in a second. So
and when you look at the Quarkus brings in all those frameworks into its ecosystems through so-called extensions. So while we started to look at CodeIto, including Drools and JBPM, into Quarkus, we started to think, okay, we definitely need to be part of this ecosystem, and we need to bring in our own extension. And that was quite a journey as well for us. We were one of the few from external team to Quarkus that builds up the extension. And to be honest, it was not just to bring a framework, but we actually bring in a new programming languages into Quarkus, so like BPMN2 or DRL or decision tables, Excel decision tables, and so on and so forth. So these have to be compiled as part of the execution of the Quarkus application. It's not just Java code. We generate Java code that needs to be then consumed by Quarkus to be part of the augmentation phase. But we started to look, okay, what do we need to do? So first of all, we need to have a Quarkus extension, and this is what we have bringing in as part of the main implementation, to make sure that we can take advantage of the features of Quarkus, such as hot reload. So we don't want you to be limited when running with Quarkus. So you have these options to actually start your application once, do the code modification, and without restarting the application, you directly have access to the change code. So exactly the same we wanted to do with CodeIto extension. So if you start your application first, then you create a process or create a rule or create a decision, and you start modifying that, you can immediately test this without restarting the application. So this is all based on the compilation provider that we have on top of the standard Java compilation provider of Quarkus. So we can then immediately get the resources files that has changed, like process definition or rule definition, and then immediately transform it into running code and push that into the hot reload procedure.
Yeah, okay. So now I would like to show exactly the same demo as we showed before, but a different running paradigm. So I have this native image. Of course, the native image is the one thing that you put into production when you are ready, especially when you want to implement this function as a service paradigm. But as Maciej was mentioning, we also have this dev mode thing, which allows you to have the auto reload. So if I do this, I'm doing exactly the same thing as before. Okay, of course, it is downloading the whole world. So I'm restarting those 3 web services, but in dev mode this time, with this Maven plugin developed by the Quercus team. Okay, so let's see if it's up and running. Okay, so this is up and running. Of course, yeah, it took more time. It doesn't take 3 seconds. It took 3 seconds because it has to do this Maven fancy stuff, as you know. But normally it takes like less than 1 second. Same thing here. And this is up. Okay. So I can do exactly the same thing as I was doing before. So I can do this. And yeah, this is doing the same thing. But at some point here I may want to change one of my business rules. So for the special country, I don't want the manager to be anymore John Doe. So I can go to the rule that is assigning that manager and put my name there. And I'm not restarting the server. I'm not doing anything here, but I will do the onboarding of another employee, and at this point is auto reloading the new rule. So what is happening here, as Maciej says, it's a bit more complex of the typical Quercus extension, because what Quercus does is this Java code.reload, but we have this stage more, so we have to realize that what is changed is not a Java source, but is a rule, and then we regenerate the Java source only for that rule, and then everything is wired in this auto-reload thing. And notice that this is another one peculiar features of Quercus. So you cannot have it with as I said, GraalVM doesn't support any native edge, and so if you want the auto-reload, probably Quercus in this situation is the only tool that could give this to you. Okay, so I think we are done. Yes, question. No question? Okay. I don't know. Was the thing interesting for you? Were you aware of GraalVM? Are you playing with it? Do you have any feedback about this? Because it's very interesting for us to know your experience if you are doing something similar. Okay.
I was not aware of GraalVM. I have a question, which is, how fresh meat is it? Is it
how fresh?
Ready?
What do you mean?
Is it? I noticed that it was released this year.
Well, there is not a stable. All this stuff that we showed today, it's a huge work in progress. So there's no stable version of Graal, there's no stable version of CodeIto, and there's no stable version of Quercus. So it's not something that you will possibly put in production tomorrow, but hopefully at the beginning of next year.
So I think what is important as well is that to some extent, certain parts of it they are stable. But you cannot holistically look at it, okay, this is stable, will not change, it's public APIs, nothing will change. That's not the case yet. We're definitely looking at, and that's why I'm asking for feedback. So in what direction we would like to see us going and so on and so forth. So it's definitely quite fresh, but at the same, it's already quite mature to be tried, used, and try to start porting your use cases into that. So it will definitely have an impact on the way you build your systems. And as we said, we're trying to go for the modern infrastructure, like the service as a function, software as a service, or software as a function, as Mario said. It is fast and small enough to actually be bootstrapped at pretty much any time. So it doesn't have to run for hours to be actually hot enough to actually serve the request properly. It could be shut down at any time, and it could be scaled up and down any time as well, because it's so small and so lightweight that you can actually take advantage of it immediately. But it does not cover everything that, for instance, Drools and JBPM support in the regular form or the traditional form, but we definitely wanted to bring more and more features into that state as well.
So the single technology are mature, I mean, at least this is my experience, the single technology is mature enough. So if you stay with a specific version of these three things and put them together, it basically works. The problem is that they are moving target, okay? So what happens from time to time is that you upgrade Graal, and then a new version of Graal breaks the native compilation on Fedora, which is something that happened last month. And then you need to wait for the patch of Graal to work again on Fedora, and also from time to time something changing in Quercus that breaks CodeIto, and we need to keep up. So once you have once you are happy with a certain version combination that pretty strong, pretty stable, you can use it. Still there are moving parts, and when a part moves, all the other part have to follow in the same direction, and this could break things from time to time at this stage.
Okay. Maybe last question, how many of you knows Drools and JBPM?
Okay, cool.
Thank you.
Thank you.